everyone. Thanks for checking out the insula training session. So in the next few minutes I'm going to take you through the basic steps of trying to do some insula mapping. So hopefully this will be educational and fun. So first up is to check out all the things you're going to need to get started. The first thing you will need is a sample brain image that I hopefully sent you by now, or you have a link to. Those will usually come in a nifty format, which has a .nii extension. In this case, I'll show you where I have it on my hard drive here. So here we have 5099 and that 001.nii, that's the critical part right here. Tells you it should be a brain image, and to view this brain image you're going to need a program called MRI-cron. So if we just search in Google for MRI-cron, you'll see the index page, and let's go to installation, and you can download the file for Windows or whatever operating system you're using, and I'll leave it to you to download and extract and run the main program. I'll just show you the Windows version, accept the license agreement, and it pops on through the series of vacuum tubes in the internet until we have the full program, and it actually comes with a few different bits of software, including stuff to convert brain image files and so on and so forth, but we're just going to use the main MRI-cron program. So once you have it downloaded, you can extract it into a folder somewhere. I guess I might as well just do it from scratch so I can make sure nothing's changed with new versions. So I've extracted this lx.zip. It is MRI-cron LX. Maybe it stands for Luxor edition or something. I don't know exactly what. And you can see here that this is not actually going to be the right version because I think this isn't compiled yet. It's too bad. Let's see what we've done here. Oh yes, LX was the Linux version. Okay. So I could just start the video again, but I think it's important for me to show you the successes as well as failures associated with this. So once I make sure I select the appropriate version, in this case win.zip, I'll download that one. It's an important skill, being able to laugh at yourself. Okay, so this is pretty much done. We'll find our win, in this case number 1.zip, because it looks like I've done this before. Let's see what we can do here. We'll extract this right here. We'll go into win 1. You see nice MRI-con directory, and you can put this wherever you want. You can put this in your program files directory, wherever you'll remember that it's been. And like I said, there's a couple different programs here, but the one we're going to use is just standard MRI-cron, right? I like to put it somewhere safe, like a program file directory, and then put a shortcut on my desktop. But here, I'll just show you using it straight out of the box, as it were. It starts off actually showing you some white matter and anatomical standard images. You can actually see, here's the cingulate bundle that serves as the kind of centerpiece of the limbic system. And you can also take a look at different templates now that it's open. So the standard templates are the CH ones. I think they're just the initials of the guy who wrote the software, Chris. So we can look at CH2 better, and you can see all these brain images, and you can actually play around for a bit, getting used to navigating the brain space. Here's the standard setup. I find I like them more horizontal. So I might go to preferences. I should show all the slices on a single row. And a really critical step, actually, I should mention right now, is you make sure you do not have reorient images when loading checked off. I'll show you what that does with an anatomical brain in a second, but I just want to orient you to how the software actually works. So I put all the slices in a single row. You can maximize it. Now we see all these beautiful slices, this beautiful brain. And so here's the sagittal slice. So when I click on the sagittal slice, you can see the crosshair moving forward and back along the axial slice over here. If I move up and down, you can see it moving up and down in the coronal slice in the middle. And similarly, I can click on any of the other views to move in the other two dimensions. Right, so here's actually moving left and right through the sagittal plane. So right side of the brain all the way through the left side of the brain. And if you really want to conceptualize that a little more easily, you can even open CH2 basic, because then you have the skull, and now when you go from right to left, you'll see fun things like eyeballs. If you go to the middle of the brain, start getting into nasal cavity down here. So more recognizable features for those of you who aren't as used to seeing it. If you want to have the crosshairs here, it can be useful to see how you're navigating through the brain, but if you don't want them, you can just press delete to toggle it on and off, and you can see that also here. View crosshairs, delete turns it on and off. Okay, so I mentioned before, first step, I guess, will be loading our anatomicals. So I have this anatomical 5099. I can just go to File, Open, or I can just drag it right on, and it'll load up. And you can see here's one of our kids' brains. A lot of this blurriness and this radial lines is because kids move a lot. It's hard to tell them from moving in the scanner, so there are a bit of motion artifacts here, but overall we can still see nice brains. We can scroll through them. In theory, we could actually render what the kid's face looks like, but we're not going to worry about doing that right now because it's not really what we're working on. There's also some anonymity issues there. But you can see this indeed is a kid in the scanner. And so one point I already raised, it's really important, is make sure that reorient images isn't already checked off. If it is, when you load an image, it'll look a bit different. It might look a bit nicer actually, like in a more standardized space. So it's tried to kind of turn it a bit, but you're going to end up with strange coordinates and when you actually end up creating the little maps that I'm asking you to make for the insula, they're going to end up in a kind of strange space. So make sure you have it unchecked, and if you've just unchecked it, it's good to reload the image one more time because it doesn't automatically update. So you can see the brain looks quite a bit different here when it's unchecked and loaded. Okay, so that's out of the way. It's important for us to discuss a little bit around what we're trying to do in this series. So the point of this study is to be able to map out the structure of a part of the brain known as the insula, which represents, here I'll open the standard brain because it's a little easier to see. It represents information in the back of the insula. So the insula here is this structure running all along here. So the back of the insula, we get information from what's happening in our body from moment to moment. It could be from the breath or heartbeat or feeling hot or cold or pain or pleasure. And that information slowly moves forward and gets integrated with other parts of other types of mental representations. And by the time we get to the anterior insula, this is really telling us in a sensory way what should be salient in our environment. So it's filtering between all kinds of incoming information, letting us know what's sensorially important, which is part of the brain's salience network. It tells us what to pay attention to, whether we need to snap out of what we're doing to focus on some other incoming sensory signal, and to sort between competing signals. And so this could be really important for autism because understanding what's happening in your body, being able to regulate intense sensations could be an issue for autistic kids who often display this kind of hypersensitivity or hyperreactivity to seemingly innocuous things like physical contact, for instance. So our project that we've been tasked to do is to help map out the contours of the insula, and not just the overall shape of it, but to divide it into specific gyri or bumps and ridges that might have actual different functional roles. I mentioned before the back of the insula is more for sensory integration or sensory landing zone. It's a primary representation cortex for what's happening inside our bodies. Whereas by the time we get to the anterior insula, now it's a filtering ranking of what type of sensory signal is important to process. So looking for changes in the shape and density and extent of these different gyri could also help us understand a bit more about insula processing and how it's different in autism. Okay, so the goal here is to map out at most 8 distinct regions. And I'm just going to see if I can dig up one of my papers that actually helps identify these regions, and this paper should be available to you also in the email link I sent out. Let's see if I go into my professional publications and we dig up the cerebral cortex article from 2013. You can see a whole bunch of brain pictures, but near the front of the the paper, you can see I've actually mapped out the different potential gyri in the insula, and I'll just take you through it now. So we're talking about kind of three major zones: a long gyrus zone in the back of the insula, middle gyrus zone here, primarily on the top part of the insula, the dorsal part, and then an anterior zone that actually have somewhat different cellular properties in terms of how granulated the cell layers are. You don't have to worry about that part so much. The important thing is we're trying to kind of recreate these divisions as we map out the insula, and I'll take you through over the next few minutes exactly how I'd like you to do that. So first thing I'd like to mention is we're going to use a numbering convention to identify these different regions. So we're going to start from the back of the brain, and we're going to go across on top and then across the bottom. So we're going to go 1, 2, 3, 4, 5, and then 6, 7, 8 along the bottom. Okay, so looking at an axial view, it's going to be 1, 2, 3, 4, 5. And the lower axial view in the middle here, 6, 7, 8. And so I'd like to make very explicit that what I'm looking for is definitely making sure you capture the long gyri of the insula, both the top and bottom ones. So that's going to be number 1 and number 6. You should definitely have some capturing of the middle gyri in the insula, so at least a number 2, and then potentially a 3 and 4. And then you should definitely have a number 5 and a number 8. Maybe also get that lower middle gyrus if you can distinguish it. So I don't want you to force arbitrary distinctions if there's really no division between insular regions, but I would like you to do your best to at least isolate these major components. And then if you see a reason to think that there's some subcomponent, then you can do that as well. So I'll take you through an example of that in just a sec. Okay, but just to reiterate, it's 1, 2, 3, 4, 5, 6, 7, 8, and at a minimum, so a brain where it's really hard to find divisions, you should still have a 1, 2, 5, 6, 8. 1, 2, 5, 6, 8. So that we're getting some coverage of each of the the 5 major zones. Okay, so when you actually output your files, I'd like them to look a certain way. And let's go through one of our already trained people's outputs here. And you can see that what Asma's done here is she has put the participant number, then underscore whether it's the left or right side of the brain, and then which of the numbered regions she's coloring in here. Okay, so your finished project or product, if we're looking at actual brains, I'm going to load this in. It's the same rating we looked at before, 5099, and then we can load some overlays. So this is a finished project. I'm going to show you how to get here, but I want to show you what sort of what the end goal looks like first. So we can just grab this path and go overlay. It's not file, which is the background, but overlay on top of it. Show us, let's say, all of the right-sided areas that she was able to capture. Boom, 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 boom. It's loading them up. It arbitrarily assigns them a color up here. We can select through them by using this toolbar to change certain properties. So for instance, I see that number 8 was put in grayscale, and I might not like that. Let me show you where they are first. So here's some right insular regions. So I'm going to turn number 8 into blue. You can see that down here, that's just turned blue. I'll turn number 7 into something a bit more appealing too, maybe a nice cyan. So I'll just turn to cyan. 6 already colored in, 5, and then this looks like it could be 4, 3, I'm not sure. See that the rest of them all actually have some color, and the white here is for overlap. I wasn't sure where the division is. So your final result is going to look something like this with a few caveats, but we'll go into that in just a second. Okay, and same thing for the left side of the brain, right? If I load her left-sided overlays here, we'll get that same kind of pattern popping up on the left side as it loads. But it's used up all its colors, so it's putting them all into grayscale, which for the mask is just going to be white because it's all just a 1 wherever it says that there is rain. So, you know, I can painstakingly go through and just light these all up, but you can kind of get the idea that each of these represents a different one of those zones on the left side of the brain. Right? So as we go to the left side, right? Okay, so how do you actually make these images? Because that's sort of the name of the game. Well, I'm glad you were thinking that, and we'll get to it right now. So first thing is I recommend working with the sagittal slices and just getting the lay of the land. So this is our participant 5099, and if I scroll out to kind of the right edge of the insula, I'm going to try to find a place where I sort of have maximal distinction. And you can almost see all little fingers of white matter that are helping us identify the different gyri. So in this case, we definitely have a long dorsal gyrus, that's number 1. A long ventral gyrus, that's number 6. We have at least one prong in the middle here, maybe 2 if you want to count that. So a 2 and 3 perhaps for the middle gyri. And then we have a cluster right here at the front that's going to be our dorsal anterior and dorsal posterior. It's number 5 and number 8. Maybe we make an argument that there could be a number 7 in here. It's hard to see how this could be 3 regions. That this could be 2, 3, and 4, but definitely I could go 2 and 3, and I can kind of scroll back and forth to get a sense of that. I can also scroll up and down on my axial, so that's the right one that's moving now, to get a sense of how many bumps there are. And again, I can see definitely there's a 1, a 2, a 3, a 4, maybe not a 5. So it's fine to just go 1, 2, 3, 4, or sorry, 1, 2, 3, 5, and then jump to 5, or so to 6, 8. So 1, 2, 3, 5, and then 6, 7, or 6, 8. Okay, so how do we actually color things in? Well, we're going to use a volume of interest tool, and it's a little tricky to use at the start, but I think you'll get the hang of it, and then it won't be too bad. So I'm going to click on the show drawing tools under draw here. Okay, draw, show drawing tools. And I'll get these different things. We're going to use the 3D inflation tool. When you click on the 3D inflation tool, it will immediately try to inflate where the crosshairs are. So let's make sure that our crosshairs are really where we want them to be, in this case on the long dorsal gyrus, area number 1. If we want, we can play with contrast, but generally the defaults are going to be what we're looking for here. So we could, if we're not happy with how well we could see things, we could try making this 10,000 or something, but how much that's going to buy us. So I would just leave that as the default. Now we're going to try to inflate a 3D image so that we can get as much of the long gyrus covered as we can. Okay, so I'm going to pick a bit of the gray matter, so not right on the white matter, but the gray matter surrounding it, so the slightly darker gray stuff. I'm going to let it inflate, and you can see, oh, it's this really big sphere, and there's actually a few options that pop up here. There's how sensitive we want the sphere to be to differences from where the actual crosshairs are. We want to know how sensitive at the very edge change has to be for it to decide there's a boundary. We want to know the radius that it's even searching to inflate the volume in. And there's something erode dilate cycles, which you can do kind of tweak the extent of the spread. We're probably not going to use that too much. Okay, you can also say that if there's ever a 0, don't even bother, right? There'll be an edge. Usually it doesn't matter if it's checked off too much or not. The thing you're going to play with most on a new brain is the differences at edge, and then you're going to play with the radius. That radius is going to be your main tool, right? So you can see already if I just play with the radius and change nothing else, I just shrinking the radius down, it's going to start to get closer and closer to being constrained really just to my gyrus. And it's better just to sort of under pick at the start and then inflate a bit, because what I can do now, once I've picked a little bit of it, I can click apply, and I can move a bit further down this gyrus, and then click the 3D button again and color it in like that, right? So I can do multiple stages. You might say, well, it would be easier just to use like a pen tool or something like that. Yeah, that might be true, except then it will only be coloring in one of these dimensions, so I would have to do it over and over again for each slice, whereas here you can see it's already spreading out in the Y and Z dimensions. So I'm going to move a little bit further out to the surface here, and really just try to capture this whole long gyrus here, this whole finger going down here, as it were. Okay, play with making the radius a little bigger. It seems like 4 is not a bad one to work with here. I could try making my radius bigger, but then saying that there has to be less of a difference at an edge to constrain it. So I say the difference has to only be 2. It's going to be much more conservative. If there's a bit of a change in density, it's going to not expand there, so that lets me play with a bigger radius. And so again, you'll have to play with these numbers because different brains will have different levels of contrast. So 2 or 3 here. So it's starting to look pretty good. I'm getting most of this long gyrus, and if I scroll kind of in and out, you can see it's still respecting the white matter a bit here. I'm going to try to catch a little bit underneath here too. so I just keep on doing that until I have a kind of nice shape that I'm happy with for this region, right? And you can always go back to the cerebral cortex paper and be like, oh yeah, it looks sort of like region number 1 here. Okay, so probably spend a little more time on it than that, maybe not, until you feel like you've kind of captured the region. You can also look that it's going enough dorsally, like maybe I want to make sure I capture this bit up here. Good. I might want to look at the sagittal side and pressing to delete toggle crosshairs and realize, oh, maybe I should be capturing around the edge there. I have to raise its threshold a bit to let it go forward, raise the radius. Just try to really sink in there and capture every bit of it. Okay, it's in some ways it's a bit better to be liberal and over capture than under capture, because if you miss something, we know we can catch it, whereas if you catch too much and we combine your results with a few other people's results, then we'll be able to sort of hone in on the part where you all agree that was brain. Okay, that's not looking too bad. So move out to the edge. You can see I'm getting a nice filled in coverage because the very edge of the insula is going to be pretty much all gray matter. See, that would be too far there. It's going into the one. There you go. Okay, so I feel pretty good about this. It looks okay in my coronals. It looks okay in my axial. If you ever think something's going too far, you can always hold shift and try to well, you can actually click the drawing tool and do shift and try to actually erase bits of it, just to touching it up. So I'm holding shift while I use that pen tool here there to do a bit of erasing. I think it's going overstepping its bounds a little bit. Okay, most of that stuff will cancel out as we average across raters. So just do your best. I'll go back to the 3D tool. Cancel. Okay, so it looks like good. That looks like my right side of the brain, region 1. So I'm going to save this now. Okay, so I'm going to save VOI, and I'll just overwrite Asma's work. So I'm going to just create another little directory here called norm example. And I'm going to change the file type to be a nifty file, because that will be able to be read by other programs. And I'm going to call this 5099 because the participant number right side of the brain, area 1. Go to my directory here, save. Once that's done, it's really important that you close the volume of interest, because you don't want to just keep adding region 2 onto region 1. And if you want to see where it stopped and started, and another way to check that you did a nice job is you go to overlay add, and now go into the area where you just saved it and add that one as an overlay. So now it's just a picture, it's no longer considered a volume of interest. So if you start doing the volume interest drawing, it will not consider this to be part of that volume. Okay, this is just something else drawn. To make it really or contrast, maybe I'll change it to green or something. Okay, so now let's say I want to do region 2 here. Okay, I can see that there's another big bump here. Actually, if I scroll in a bit, I can see that there's sort of a region 2 here and a region 3, and then maybe a region 4. So let's do region 2 here next. Start coloring it in. It's a little wider than I'd like, or maybe I want it to be a little more conservative at the edge. Not bad. This could kind of go under a little bit. Maybe it looks like some gray matter there. Looks okay on my coronal. If I scroll outwards, it looks like it doesn't totally survive out there, but I can still, every time I press 3D, it's going to try to extend, and I want to try to avoid overlap. That's why it's nice to have the overlay there again. And you can see now in the different views, I'm really getting a nice blob here in this middle insula. So this is going to be my region number 2. If I look at my coronals, it doesn't look too bad. There's a bit of overlap where I don't want it to be, so I can pick the pen and hold down shift and just circle. Oops, that's too much. Control Z undoes stuff, by the way. Maybe Apple keys out if using a Mac. So I'm just trying to get rid of that overlap region. Similarly, we move out. It doesn't look too bad. Like here, I think it's curving around a bit in the coronal, so I don't really want that either. Again, if you make kind of small random errors, probably those will collect out. Oh, I forgot to hold down shift there. So I'm going to hold down shift just to solve this one slice. Really try to just get rid of all this stuff. So it's nice and clean, just an insula. We don't want to extend beyond our boundaries. Okay, good. So this will be my region 2. Save VOI, ROI. So you can see it remembers that it should be a nifty file now, and it even remembers the last file name, so it's, I don't have to type everything else again. Number 2, and again, I'm going to go to draw, close VOI, so I'm not adding to the current VOI, and add this in part 2 as an overlay. Maybe I'll color that one, and yeah, blue's fine. Now I'm going on to region 3, which is right here. Let's go back to my 3D tool. Sorry, just cancel that. I'll use my crosshairs again to look at where I'm starting. Start right in the middle of that. So my 3D tool, I can expand a bit because I really want this thing to spread throughout this region. I'm paying attention to what happens in my coronal and axial slices to make sure it's not spreading too far. But I might still want to scroll a bit and see what I'm covering. Like maybe I want it to get the right cap up here, so I apply and then again. Oh, that's nice. And then I scroll out a bit too, so I'm going to move out towards the surface. I can see, I haven't really done a great job of covering the very surface here. So even though region 2 didn't really kind of come out this far, region 3 does. So I want to kind of give it a fighting chance here. Good, so that looks pretty good. I'm going to save that one as region 3. Again, I'm going to close it, open it as an overlay. Make this one cyan. Okay, so you can see we have our 3 regions here now. Not bad. And then here's our next nice big gyrus here for region 4. I don't think, or for region 5. I don't think we're going to fit in another region that will call for it. So we're going to jump straight to 5. Start inflating here. Looks good. Follow it around the bend a bit. So I can really capture that. Looks good. I'm kind of missing this bit in here. Yeah, not bad, not bad. Okay. As I move all the way out to the surface, I can see it's mostly filled in at the surface where there shouldn't be a lot of white matter. So I like that. I'm pretty happy with that. Draw, save POI. Remember here, this would be this is our 4th image, but we're not going to actually get a 4. We're going to skip to 5 because 5 is going to be the most anterior of the dorsal ones, and we're not going to be able to fit 5 on top. So it's going to go 1, 2, 3, 5. So forget everything you learned in school about counting. Okay, I'm going to close that VOI. Open 5 again so you can see it. I picked a nice purple color for us, beautiful. And I'm going to see what we can get on the ventral side of things. So we're going to get this long gyrus down here, the ventral long gyrus of the insula. So bam, move a little further down. And I want to really make sure that I go all the way out to the surface, so a bit more laterally, away from the middle line of the brain. And color all this in too, because this is all part of it. This is where we're really going to get a lot of volume, is that the surface of the insula, because it's away from the gray matter, it's where we're going to get a lot of the actual neuronal bodies that make up the gray matter, and not all the long connection tubes that make up the white matter. Okay, so not bad, not bad. Just respecting the hint of white matter in here a bit. Yeah, not too bad. And as I move out, we get a nice broad bit of coverage. I could even go a little further down. Call this all long gyrus. Okay, there's a bit of white matter there, so it's kind of resisting it a bit. Okay, and then when I look at the front here, again, I don't see a really great distinction here between, get rid of the crosshairs. What would be number 6 and 7? Oh, I almost forgot. We have to save number. We have to save number 6. And then close it. Add it as an overlay. Okay. So sorry, we don't see. I don't see a great distinction here between 7 and 8. Though here you can see that there's a bit of a cleft. And so I could make the argument that this is going to be my number 7. Right? And then as we go in, I just going to make sure everyone, and then this part right in here is going to be number 8. Because you see there's that white matter dividing it right there. If you can convince yourself it's there. If you really don't see a distinction, then you just make it all number 8. But I'm going to save this as number 7. Okay, close, draw, close VOI, overlay, open number 7 so you can see where it ends. Use the same color, one of the same colors as before. It's fine. You can pick whatever colors. Most of the colors you'll use are these front 6. say I want to make this one, I don't know, so it's already signed. I can make it wide also. That would make it be a bit confusing. The main thing is you just don't want it to be red, so we can see where the new one is. And so our last one on this right side, number 8, I'm going to fill in there. Move it a bit more, fill in there. Try scrolling in, see if it ends in an appropriate place. Yeah, not bad. I might want to even get it to color in a bit more here. And then this stuff here is really more like white matter, right? I mean, I might start second guessing myself and thinking this is also a long gyrus, so I can come back to that, and I'll show you how to do that in a sec. So just to finish up number 8 here, I'm going to save this as number 8. And then I can close that, and let me just open them all up. Except I'm not going to open up number 5 because I realize I'd like to put a little more here on number 5. So open the rest of them. And let me close all the overlays and do that again. Okay, so shift select them all, control click to get rid of 5, or you can just add them one at a time, whatever floats your boat. Okay, then here I'm going to go draw open VOI. Oh shoot. Got 5 and 6 confused again. I'm going to do that one more time. So close all the overlays. I'm going to open them all except number 6, because this back one I wasn't happy with was actually number 6. Okay, so there you go. Load them all up. Okay, so and then here I'm going to go draw open VOI, not just open overlay. Change that to nifty, or here it just says neuroimaging. I'm going to open number 6 again, but here I'm not opening as an overlay, I'm opening as a VOI, which means I can keep adding to it. Okay, so there's number 6 again here in red. And so if I want to find that little bit that wasn't covered, that I was really thought, oh, it should be in this part up here, I can now click and add more to it, right? Just as neurotically as I please, but you know, just trying to do a good job. And even here, maybe this is going a bit far in, so decide whether that's what I want to do or not. I can close the VOI, reopen it if I do something catastrophic. Neuroimaging, open. Number 6 again. Okay, well, how far in really should this go? So yeah, maybe just here a little. But you can see in the chronal this is starting to get pretty far inside. I might just want to try to do that. So you can do little touch-ups like that, and then just draw, save, and overwrite the one you already did. Okay, so as you can see by the mistakes I'm already making, you really want to make sure you're keeping the numbers correct. You can make a little reference sheet. I think I might have one of those that I'll attach as a link where it actually puts the number on each region to make sure you're labeling things correctly, because we'll have a lot of trouble finding overlap if different people are calling different regions different things. And that naming convention again, if you go to the directory that I've just made, you can see is subject number underscore side of the brain underscore number. And so when I'm done with the right side of the brain as I am here, I can close all those overlays, close that VOI, and I can move to the left side of the brain and repeat the process now. And actually the left side of the brain is a bit easier, it looks like, to make out on this particular person than the right. We got these nice long finger here, and then a 1, a 2, a 3. So you actually get 1, 2, 3, 4 at least easily here, and 1, 2, 3 on the bottom. So we'll get at least 7 on the bottom there too. There may be some brains, like I said, where you can only get 5. You can get 3 on top and 2 on the bottom. That's fine. You just do the best you can. Okay, and that's pretty much it for drawing out the brains. If you need extra papers talking about insula anatomy, I'm happy to give that to you. But just to start with, just make your best guess. Try to be bold. Try to cover as much of the insula as you can, and so you don't have overlap, but you don't have a bunch of gray matter spaces between regions also. If you can come up with something that looks kind of like this, right? Like, not saying that I'm perfect at this, but that if you're just getting these kind of ballpark regions and they look like they're, you know, anatomically informed where those boundaries are, we're going to be in pretty good shape, because we're going to find agreement between raters, and that'll really help us map it out. Again, you might have little dots missing here or there depending on your threshold, but make sure you get those overall shapes down. Okay, and then I'll give you feedback on how that goes. So I think that about concludes the training video. Now it's up to you to try things. It'll probably take you the better part of an hour the first time you do one of these things. I really suggest you do use the 3D tool, even if it's annoying to use at the start, because if you start trying to just draw on each slice, it will take much longer. And with practice, I think you'll be able to breeze through one of these brains in about 15 to 20 minutes. So just for this first stage of training, take your time, try to get it right, and then we'll work on speed after we've got accuracy. And that's about it for me. So yeah, thanks for watching, and I hope you had a fun time. Okay, bye.